Are you studying computer science and find that some of your peer students seem to be naturally gifted or talented at it, and then when you study yourself, it just doesn't seem to click? Well, I've been asked this question a few times by friends, and they found my advice quite helpful, so I'll be sharing it with you today. In this video, I'm going to teach you how to study smart, and which study methods are most effective, specifically in computer science, that I've used and found helpful to achieving top grades while studying for a similar amount of time. This video will be split into 3 categories: how to build a realistic timetable, taking effective notes during lectures, and the best study methods for information retention to make sure you actually remember and understand what's going on. Before you actually get to the studying tools and techniques, one of the most important keys to getting good grades is the realistic study routine. It's better to set a smaller realistic amount each week that you actually commit to, over being too ambitious and going from 1 hour a day to suddenly 4 hours a day in one go. The key thing here is to balance your schedule around how you like to learn. Computer science is generally quite a theory-heavy topic, which means it requires a lot of processing of the information rather than necessarily being something that requires mostly memorization of facts, for example. This means I prefer spreading out my papers and generally didn't do more than 1 hour per day for each subject, to let the information sit and be in my head to be processed in the background while I learned other subjects. This way, later when I revisited it, some passive new associations had already been made implicitly. Another important thing when time scheduling is to take regular breaks that best suit you. This is another step that requires you being realistic with yourself, because you really need to identify and understand what type of break best suits your needs. Personally, I like focusing in chunks of 45 minutes before taking 10 to 15 minute breaks, which may seem long to some people, but to me, it keeps me energized and gives me adequate time to briefly rest my brain before continuing to study. I also prefer to schedule that spread out study over as many days of the week as possible, generally leaving out Friday evening to hang out with friends, and the rest of the days would have 1 to 2.5 hours of solid focused study per day. Keep in mind that this timetable obviously changes a lot when it comes to exam and test periods, where I tend to study a lot more. My final tip for study routines is to try not to find the perfect timetable before implementing it in the first place. It took me many revisions and adjustments before I could find the ideal combination of work and play, so don't be too hard on yourself. Now let's move on to note-taking techniques during lectures. If you're familiar with note-taking techniques already, you probably know there are many different methods that are widely popular, and if you already have a favorite, then go ahead and use it. The key part here is that for most computer science papers, you should not be taking down lecture notes or bullet points already on the slide. This is because, as I mentioned earlier, CS is quite a theory-heavy topic, so if your professor already gives you slides, then there's little reason to be writing down those same notes again verbatim. Rather, the focus should be on building a deeper understanding of what's being taught. So, with that in mind, here's an overview of a couple of note-taking methods that I mix and match depending on the content being taught. Also, I'll be making a more in-depth video of each study method in the future, going over how to actually take notes effectively during lectures, so subscribe if you're keen to see that. The 3 note-taking methods we'll be going over today is the Cornell method, mind mapping, and writing on slides. The Cornell method is something I recommend for if you're not given a copy of the lecture slides and need to capture key points while still forcing you to be in review mode. It's also perfect for content-heavy courses, such as when you're first learning how to program and you need to know what each function does. The method revolves around dividing a paper into 3 sections: notes, cues, and summaries. My favorite aspect of the Cornell method is that it essentially encourages you to write down summaries right after you finish the lecture or whenever you're done studying. And these summaries can be reused during the information retention phase, which we'll be going over soon after. Mind mapping is one of my personal favorite methods for note-taking, perhaps because I'm a visual learner, but it's also very intuitive to use. It's one that I found extremely applicable when I studied computer science subjects. This is because, well, actually, if you think about it, a lot of CS theory falls very naturally into a mind map form. For example, a graph data structure is essentially a mind map that consists of nodes. So I found it very easy and intuitive to link together concepts and ideas across different but related domains within the field of CS, which made everything click together and really strengthened my understanding and foundations of CS pretty quickly. Lastly, writing on slides. This method is one that may not be applicable to every student, but I find nowadays, especially with online learning being the norm, slides are pretty accessible, and most lecturers, unless they really hate you, do give them out. The key thing here is to be actively listening to the teacher and making notes about what they're saying that is not directly on the lecture slides already, or writing down any questions or key concepts you may have about the topic. If you already have the slides, 80% of the work is done already, and you should really be trying to focus as much as you can on how the content is being taught, rather than worrying about if you have the content down and rewritten in a different format. I've seen countless people just rewriting their lecture slides, which is really just a waste of time. So now we have some content to actually sit down and learn the information, which is probably the hardest part, but you can't avoid it and procrastinate forever. For computer science, I find that this step is one of the most important steps for getting good grades and doing well on assignments, actively learning the content. Taking notes alone and memorizing how to implement a data structure or what a function does isn't really going to help you get good grades if you don't understand what the function is being used for and why it exists in the first place. These are a few key questions that I ask for basically every concept I come across, and over time, you'll gradually build links between topics that acts as a strong foundation layer that you can associate with each new thing you learn. So how do we actually retain this information? Well, it kind of depends on what note-taking method you used above. The Cornell method already has a summary that you wrote, and mind maps, well, depending on how you drew them, they can be repurposed and redrawn into a more condensed version. However, if you wrote on slides, it is probably recommended that you cut it down to a few bullet points and make some sort of summary out of it. These are all accessible ways that use your existing notes and reinforce the knowledge and hard work you've already put in. From there, if the topic has some sample questions or problems, you should work on these first and, if possible, apply some concepts together and try to find patterns and identify what is actually going on. If you get stuck here, then you can usually find some sample practice problems from lecture slides or maybe online, and there you should try your best to dissect the decision-making process behind how they problem solve the question. My last tip for you is, if you want to keep that information in your head, try using flashcards. Quizlet or Anki are both free apps that are relatively easy to set up, and what you want to do is write down flashcards on how you solve certain problems or key concepts that you summarized, and then at the start of each study session from your timetable, you can go over them. This is one of the best methods to retain the information over time, as revisiting material over a longer period of time will reinforce this knowledge and highlights it through the spacing effect. This is why, even if you've had success cramming in the past, you're pretty unlikely to remember this content in the long term, because it takes chunks of information over time revisited to actually secure a spot in your memory. Okay, so that was probably a lot of information, so let's do a brief recap of what we've covered today. First, we went over building a realistic study routine and the importance of regular breaks as well as spreading out our subjects in order to maintain consistency and prevent burning out. Next, we covered note-taking during lectures, and I emphasized and highlighted the importance of effective note-taking to ensure that you're an active learner rather than being a passive one. This was achieved through 3 methods: the Cornell method, mind mapping, and writing on slides. Lastly, in the information retention phase, we covered how it was important to build key concepts and link them together across in CS in order to build a strong foundation. We do this through mindfully going through our notes that we've taken down earlier in order to reinforce the knowledge and concepts that we've learned, and this is achieved through flashcards and summarization techniques so that the knowledge can be retained in the long run. Thanks so much for watching until the end. Leave a comment if this helps you out, or if you have any questions, I'll be sure to answer them. Peace.